everyone. I'll start a bit with the motivation for this talk. Detox is a gray box testing solution for mobile applications. It manages sync between test code and the app, so the users don't have to do it manually. Despite eliminating the user's need to do so and the abundant documentation and guides, developers and testers can still get tripped upon bad usage patterns, misconfiguration, and suffer from poor test stability. We know and we feel this pain every day internally at Wix. So in this talk, I aim to explain how Wix is using Detox internally and how we manage configuration, how we fight flakiness, and some of the best practices we've developed over almost 3 years building and using Detox in our CI process. We'll also discuss the endless strive towards zero manual QA, which always seems in reach if you only overcome that just one last technical hurdle. So hi, I'm Rotem. I'm a software engineer working at Wix. In the past 4 years, I've been working on Detox since its inception. In the past 2.5 years, I led the team behind Detox, and recently I left this role in order to join Wix's server infra group. In the picture, you can see me with two of my favorite side projects, especially now during the third full lockdown in Israel. So in order for us to get everything into the right context, we'll start at the beginning. Detox was built at Wix in order to solve a growing problem with flaky end-to-end tests, especially on our then new React Native application. The main idea was to follow the approach successfully executed by Espresso and Earl Grey. These are two gray box testing projects created by Google for Android and iOS respectively. As opposed to black box testing, where the tester needs to decide how much time they wait for the app to finish what it's doing before sending the next action or expectation. With the gray box approach includes running a synchronization mechanism inside the app under a test to detect the busyness and the idleness of the process. Then it only interacts with the app when it is considered idle, meaning it has no more events to handle. No more network requests, no more animations, no more transitions. It's actually doing nothing. This approach guarantees that any action or expectation that with the app will only happen when the app finishes processing everything, and nothing will change anymore until the next user action. In order for us to talk of how we incorporate end-to-end testing inside Wix, let's also discuss how Wix's mobile app is architected. So in a bird's eye view, there are 4 types of parts which we build the app from. The first part is what we call the engine. It's the backbone of the application. It's an entity that includes all the native code and all the API registry for all the modules that are built on top of it. So they can communicate with one another and with the engine. The infrastructure libraries used with the engine, most of which are actually open source, and the engine itself are usually written in languages native to the platform. So it's Objective-C and Swift for iOS and Java and Kotlin for Android. And alongside all this is wrapped with a unified JavaScript API. The second type is our UI library, aka React Native UI Lib. This is an open source project, and this is the project which all the UI is built on top of, including and it includes a lot of JavaScript and native components. Module is a single product. It's a blog, or we have a lot of them in the app. These are this can be a blog, store manager, CRM, chat. We have a few of those, and those expose their API, expose an API of itself to consumers, and also it consumes the engine's API. It consumes, of course, UI lib to build its own UI and other modules, of course. And this is the actual product implementation. So here we'll have most of the screens and the business logic, and all of those will be defined inside a module. And the fourth type is some other libraries, either if it's open or closed source. These are somewhat disconnected from the release process, actually, and because they are inherently just transitive dependencies of the above-mentioned parts. New releases are being updated manually with those, mostly through PRs, to the engine, to UILib or a module. And regarding testing, they're being tested and treated separately with their own build, with their own test suites. Each of those parts has its own independent CI process. And when everything looks good to us, a new version can be published for everyone to use. The final stage is to take all of those with a configuration file and build one big binary that includes everything. And this is the app we released to Google Play and the App Store. Now that we have a slight overview of how everything is laid out, let's discuss testing. I will not discuss unit tests because those, though we have a lot of them in all the projects and they run all the time, but they mostly are very easy to run and they're very, very cheap to run. On the end-to-end side, we differentiate between a few types of tests and split those into a few test suites and execute them in different timings and different stages of the development cycle. Here are 4 types of end-to-end tests that we have. So the first one will be production end-to-end. Those are fully functional, those run on fully functional app with very minimal mocking. Wix use a lot of experiments and A/B tests all around. And with this type of tests, we want to make sure that we get the same features and tests on every test execution because they can differ on different runs of the app. So we developed an experiment override mechanism that enables configuration of the predefined experiments blob and at the beginning of every test. And this launches the app with these experiments running, thus ensuring that we never get different behavior while the app is under test. Production end-to-end run whenever a module owner wants to GA, publish their own work into the full app. Mocked end-to-end tests, these tests are actually just with mocked server endpoints. They can run on specific module or on the entire application. We usually just do it on a single module. They do not interact with production environments. This controls the mock server, and we're able to control the mock server's output and tests and test the actual module behavior in predefined states. The big upside is the ability to control all the inputs to the test. And then we have consistent inputs with the local mock server, which guarantees consistent output of the test, usually more stable and a bit faster than production end-to-end. And these run on CI on every push to the module's codebase. We also incorporate screenshot testing. Those are mostly used in our shared UI library, the UILib. Detox doesn't have any sort of screenshot comparison mechanism, and we take those, it just knows how to take screenshots on demand. We know how to do both device level screenshots and element level screenshots to be compared with external libraries. We use apply tools in order to get smart comparisons to avoid false positives on slight pixel variations. It's worth mentioning here that slight pixel variations is not an uncommon issue. It can happen by comparing screenshots taken with 2 different graphics cards or drivers, for instance. So if you take something with the local dev environment and you try to take a baseline on that machine and then run the test on the CI machine, you'll have different screenshots. This can easily fail and have not be handled properly. So component testing, is another type of testing that is done. Some of the modules incorporate testing of actual React components states. These load components with their own states by and then switching state and props programmatically throughout the test. This is being done on top of Detox with Compot. It's our React Native component testing library. And these run on CI on every push to the module's codebase, just like we do with mocked end-to-end. So how do we choose what to test? Wix app modules are written 100% with JavaScript or TypeScript. And this means that most of the module business logic runs on the same code, runs with the same code on the two platforms. A lot of times, product developers find the bug related to their module manifests on both platforms similarly. So the bug which manifests only on one platform usually is an issue with an infrastructure library. This means that module devs are able to get pretty good coverage by only running E2E on one platform on top of their module. This is not, however, mean that the whole app can be tested on one platform. All of Wix's infrastructure libraries are running tests on both iOS and Android. So in order for us to trust end-to-end tests, they must be very stable, but also provide a good insight of what's happened and why the test fails. Over the years, we try to improve this in two ways. The first is by developing a series of tools to help us figure things out: view hierarchy dumps, trace logs, videos, test timeline, graphs, and also trying to make it easier for users to understand why tests hang when they do. And it's usually caused by some sort of something that keeps the app not idle, either if it's animation or a network request or something similar. The second is education, and the latter was mostly directed internally at Wix engineering team, but some of it also reached our documentation. So I want to go a bit over the second one. So two things that are very important for us to get or to have when we have when we want to have stable end-to-end. I want to have test isolation. This is probably one of the most important tips that I can give you. Make sure that every test is starting fresh. Make sure it is not dependent on execution of a previous test. The second one is input consistency. An app might have multiple inputs that might change the behavior when running. Various responses from servers. Some application might have experiments and A/B tests executing on different code paths in the app, causing it to behave differently during different runs. So you must make sure that these are handled and configured in your tests, and they're identical throughout all the iterations of those tests, whenever it's locally or in CI. At Wix, we developed an experiment override mechanism that helps us predefining those experiments and ensuring it works well while the app is under test. So regarding configuration, as Detox becomes more and more mature, we get more features and tighter integration with Jest, which we usually do that in order to leverage some features available in Jest or new cool features in Detox. Those configurations become harder to handle. Although the documentation itself is pretty good, it's very hard to keep track of the config. So as mentioned before, this is actually all the configuration files that we have in Detox in one of our internal projects. So as mentioned before, Wix app is built from many independent developed modules. Each has its own Git project and build configuration in CI, and each of these was required to add the Detox configuration files into its own repo. Most of these were similar config files. And during the last 6 months, we got to a realization that it makes zero sense to keep those this way. And we went for and unified the configuration for everyone. We created a library that helps us share everything. These configuration files are an extremely important yet fragile part of Detox. It is easy to misconfigure, and whenever it's misconfigured, you get subpar results. For those reasons, we have decided to supply some sort of basic shareable configuration right out of the box with the open source Detox, and we hope to do this sometimes in the near future. This is something we already do internally. CI for mobile is one of those things that are still pretty hard to nail right out of the box solution. So we've tried all the major SaaS CI solutions. Running iOS E2E on either Circle CI, Travis, or Bitrise is pretty easy. And the big problem was with Android emulators. The real insight here is that Android emulators run better on Mac VMs than on the offered Linux ones. They are guaranteed to run with nested virtualization on Macs, which is required for running x86 emulators. We basically run a VM, the Android x86 emulator, inside a VM, which is the Mac OS, so it requires nested virtualization. But those still miss hardware acceleration and the resulting with poor emulator performance, although it works. So the current solution for our in-house CI includes VMware ESXi on Mac Pros in Mac Stadium with Mac OS VMs. These work for both iOS and Android, as VMware supports nested virtualization. But performance for those machines is still pretty bad. Compilation time is slow and test parallelization is somewhat limited. We cannot use a lot of simulators or a lot of emulators on the same machine. And by that, slowing down or not slowing down, decreasing the amount of time taken to run it. So our next gen setup includes bare metal Mac Minis, such that run everything on the host OS. These have much better performance, at least 2 times faster than the VMs on an Intel-based Mac Mini. Hopefully, we can do it even faster with Mac Minis with M1 chip. On the Android emulator front, we recently released support for GeniCloud SaaS devices, and we orchestrate all those with Detox right out of the box. By using GeniCloud emulators, we gain 4 key benefits. The first is we drop all prerequisites for the CI machines, as these emulators run remotely on GeniCloud's infrastructure. The second is we get better performance per individual emulator. In our case, it decreased a 35-minute suite with 2 workers running Android emulators to 15 minutes with 2 workers running with GeniCloud emulators. The third is maybe the biggest benefit is the ability to scale infinitely and run as many workers as we want in parallel. So all the SaaS CI options that we talked about now become valid as they can be used for builds and test orchestration and offload all the device emulation to GeniCloud. The main caveat with GeniCloud is the fact that this is a paid service, even for open source projects. So the holy grail for the release process is to have it all automated and fast. As we continue to solve our problems, we get just a bit closer to the goal on each step. The main issue we're facing today is the test execution speed in CI, especially for elaborate production end-to-end suites. This is absurd. The absurd is that it is faster for our QA engineers to go over the test suite manually than to wait for 150 minutes for everything to finish. So they actually do it. This will not stay this for long, though. With just a bit more work, we'll get much faster test suite execution with potentially infinite scale. Thank you.